In this video, I'm going to go over the 5 questions from day 1 for these review problems. Hopefully you're doing these like each day that we post them. If you are doing more than one at a time, that's okay, but we're trying to keep you guys from, cramming at the end. We want to try to space out the preparation, okay? All right, so here we go. Number 1 says the distance from Kincaid to the Alamo is 189 miles. What is the distance in centimeters? So I'm going to start with 189 miles. All right. And I'm going to first convert that to feet. So I'm going to use this first column, second row. 1 mile is 5,280 feet. So I put mile down here. So 1 mile is 5,280 feet. All right. Next, I can go from feet to inches. So I'm going to put 1 foot down here, and we have 12 inches in 1 foot. And last but not least, I want to move to centimeters from inches, which is going to be this one up here. So 1 inch down here is the same as 2.54 centimeters. All right, then I'm going to move to the calculator to essentially, since all my numbers ended up being in the numerator, I'm just going to multiply all those numbers together to get how many centimeters, okay? So I'm going to go to my calculator. I'm going to multiply 189 times 5,280 times 12, and then finally times 2.54. So it gives me, let's see here, I think it's 30 million. Okay, so 30,416,601. Okay, so 30,416,601, and then what is my decimal here? Decimal is 0.6. Excellent. So 0.6 centimeters. All right. So that's the first one on dimensional analysis. Okay, number 2. We want to find DE. So we're going to first show that these are similar triangles. So I'm going to have my small triangle. So triangle BDE is similar to triangle BAC. All right. So when we look at this, we're going to set up, and this is where you want to be careful, right? Use that theorem sheet, because if this X and this 18 were over here, I would do this problem differently. Okay, so just keep that in mind. When you look at another review day questions, you'll see kind of a variation on this question. So maybe you got go back and compare it to this one, so your brain knows which proportion to set up. So because it's given like this, I'm going to set up 8 over, right? So I use that 8, and then I'm going to use this entire length here, which is 24. So 8 over 24 is equal to X over 18. Okay, so keep in mind there, the common mistake is kids are going to put 8 over 16 equals X over 18. That would be incorrect. So it's also on one of our tests. I think it was unit 5. So go back and take a look. Make sure you got that correct, or you did corrections on it. I'm going to reduce the 8 over 24. That reduces to 1/3 before I use my cross multiplication. So then I do cross products. So 3 times X equals 18 times 1, which is 18. So X is 6. Now I'm not finished. The problem did say to find segment DE. In this case, segment DE is X, but make sure you write segment DE equals 6 units. That's number 2. All right, number 3. We have Jess looking down at a Frisbee that has landed 4 meters away from her feet. Her eye level is 1.7 meters off the ground. So I'm going to put Jess right here. All right, so this is Jess. Looking down, I'm going to put her eyes, looking down at a Frisbee, okay? And that Frisbee is 4 meters away from Jess, from her feet, and her eye level is 1.7 meters off the ground. All right, this creates that right triangle, and we want to figure out the angle of depression. So remember, with the angle of depression, right, if I do a horizontal line from her eyes, right, that angle of depression is right there, which is actually the same as the angle of elevation if you were looking up from that Frisbee, looking back up towards Jess. Okay, so I'm actually going to find this theta, which is the same as this theta up here, which is the angle of depression. So I'm going to use my SOHCAHTOA. All right, choose one of these. And when I'm looking at it from the perspective of this angle, I have the opposite side and the adjacent side, so I will be using tangent. So tangent of theta equals 1.7 meters over 4 meters. Now I do want to find an angle here, so I'm going to write theta, my angle, equals tangent to the negative first power of that fraction, right? So make sure you write this step so we can see that exact answer, right? It does say in the instructions to give an exact answer. And then we're going to go to the calculator so we can find an approximate for that angle. We're going to round to the nearest degree for this one. So tangent to the negative first power is here, and my fraction is 1.7 over 4, which is to the nearest degree approximately 23 degrees. All right, that is number 3. Go to number 4. All right, note, so number 4 has 3 different ones here. We're determining if triangles are similar or not. Don't forget, these are the different ways that we're trying to say that they are similar. Angle, angle, similarity, side, 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 similarity, or side, angle, side, similarity. Now this first one, I see in these 2 triangles, they give me 2 out of 3 angles. So I can use my understanding that the sum of the angles in a triangle is 180 degrees to find that third one. So 70 degrees plus 35 degrees, that's 105. So then this one's got to be 75 to add to 180. This one here is 75 plus 35, which is 110. So this one has to be 70. And you can see that all 3 angles are the same. So I can say that these 3 triangles are similar using angle, angle similarity. All right, so again, it doesn't matter how you write the order of your letters. Just make sure they match, especially in this case, the angle should match. So if I start with A and F is similar to triangle, I need to go to the first one is the angle is 75 degrees, which is O. Then the 35 degrees, which is T. And last but not least would be the 70 degree angle, which is G. So make sure those match. That's going to be key. You can still get a lot of points here, but we are checking to make sure that the order is correct. Okay, so by angle, angle, similarity. Okay, let's do the next one. Now they're giving me 2 side lengths and the angle in between. So I'm really going to be checking for side, angle, side similarity. All right, so the angles are the same, so that's good. And then we're checking to see that the proportions are going to be the same. So I'm going to do the small side of 8 over the small side of 12, figure out what that is. All right, and then I'm going to do the bigger number, 16, over the larger number, 24. So if these reduce to be the same, then I can say these triangles are similar with side, angle, side similarity. All right, so divide by 4, I get 2/3. Divide by 8, I get 2/3. So they do end up being the same. So I'm going to say triangle DFE is similar. So I went small side first for DF, and my angle F is in the middle, so angle B. So I got to go A, B, C. Should be good there. By side, angle, side similarity. Okay? All right. Last one. Last one has 3 different side lengths. So since they gave me all 3, I'm going to be trying to prove these are similar with side, side, side similarity. So I'm going to set up those 3 ratios again. So I got 3, the small side, over the small side of 6. The middle number 4 over 8. And then the largest side 6 over the largest side 13. Let's see if these reduce to be the same. So this is 1/2. This is 1/2. But unfortunately, this stays 6/13. I can't reduce that anymore. So remember, all 3 have to be the same. So these triangles are not similar. All right, so all 3 of those have to reduce to be the same. Okay, let's do last question. Number 5, we're going to give an exact answer to find x and then round to the nearest hundredth. So again, this is SOHCAHTOA. We have a right triangle. I can't use any of my special right triangles because the angle is not 30-60 or 45-45. So let's see, we're trying to find from this angle of 43's perspective, that's the adjacent side, and then across from the right angle is the hypotenuse. So I will be using cosine. So cosine of 43 degrees equals the adjacent side x over 7. I'm going to move the 7 over with multiplication to get 7 times the cosine of 43 degrees equals x. That's my exact answer. And then I can give an approximate answer by going to the calculator. So 7 times the cosine of 43 degrees, which is to the nearest hundredth approximately 5.12. All right, guys, that is it for the first one. Don't forget to check back for some more videos on the rest of these, right? Hopefully you're trying these before you watch the video, or at least like giving it your best shot. Check your theorem sheet. Always have that theorem sheet out when you're doing these, and then come see us on Wednesday before the exam if you have any other questions. All right, good luck.